Hi everybody, I hope that all of you are doing well. So today we will have lab number 6, and in lab number 6 we will study the transformers. So what are the transformers? Transformers are tools like this. So people use them to transfer the voltage, maybe from higher voltage to lower voltage, lower to higher. So the transformer can do that. And also the transformer can be used with some electronic components to convert the AC current to DC current. So we are not interested in the AC and DC current, but right now we are interested in understanding what is the transformer. So to explain that to you, let's come here. And don't worry, so during the sessions we will have more explanation about the transformers. So what we have here, we have a coil. So this is called the primary coil. And we have another coil here. This is called the secondary coil. And each one of these coils have a number of turns. So as you can see here, maybe here we have like 1, 2, 3, 4. We have 4 turns. And here we have 1, 2, 3, 4, 5 turns. So simply here we have a wire, and this wire was covered with the insulator. So you can see that this wire will hold current, and if there is current flowing in this wire, that will create something called magnetic field. Yeah, so if the current is flowing in a wire, so that means there is a magnetic field will be created around that wire. So if you go to session number 3, week number 5, you will have like a good idea about what I'm talking about. How can the current produce magnetic field, or how can the magnetic field produces current? Yeah, and we will have more details about this in session number 1 for week number 6. So don't worry about that. But for now, keep in mind that we have just 2 coils, and each one of these coils has a specific number of turns. What we will do, we'll apply voltage across the primary coil, and then we will see what do we have across the secondary coil. So primary coil, secondary coil, primary voltage, secondary voltage. So this is the output, and here we have primary turns, or primary number of turns for this coil, and here we have secondary number of turns for the secondary coil. And since there is a magnetic field that will be created right here, this magnetic field can create current in this coil right here. So we will go through these steps in details if you watch session number 1 for week number 6. But for now, let's continue. And as you can see, this is the transformer that you can see when you go to stores, for example. It has like different shapes, depends on the company, but normally it has something like this. So yeah, you can see that we have iron sheets here. Inside here we have the primary coil and the secondary coil. Okay, so this is more complicated, but in this experiment we will try to have something more simple. So in this experiment we will have these equipment. So we will need the oscilloscope, we will need the function generator, and also we will need some coils that we made here in the lab. So this coil has 100 turns, This coil has 100 turns. And another coil here, it has 200 turns. So this coil has 200 turns. And also we have another coils that made professionally. Yeah, so these were made by a company, so you can see that they are turned perfectly. Yeah, so these are the coils that we will use, and these are the material that we need for this lab: oscilloscope, function generator, 20 kilohertz, as you can see here. This is the frequency, and the voltage here is 10 volt peak to peak. The signal has 10 volt peak to peak. And we have some coils here. I will use these coils as secondary coils, and here I have coil and I will use it as primary coil. So the primary coil has 339 turns, and this coil right here has 661 turns. This one has 100 turns. This one has 200 turns. And I will try to use them. So I will use this as primary with this. So this is the secondary. And then this as primary with this one as secondary. And then use this one as primary with this one as secondary. Okay, so I explained by the beginning of the lab what do I mean by a transformer. So hopefully that's clear, and you will find more information in session number 1 for week 6. So let's get started. And what I would like you to do here, I would like you to look at this signal right here. So firstly, I will show you the oscilloscope, the function generator signal before we start. So this is the function generator signal. I will connect this coax cable right here, as you can see, and then connect it across the function generator so you can see the signal. So that's great. This is the signal that we have from the function generator. I will adjust it. So what do we have here? Let's count the number of squares. We have 1, 2, 3, 4 times 2. So 4 squares times 2, that give me 8 volts. I will show you that by zooming in. So let's do that. Okay, so you have 1 square, 2, 3, 4 times 2 volt. So that will give me 8 volt from the function generator. Great. So this is the first thing that we need to do. So let's write that down, that the voltage or the signal from the oscilloscope has 8 volt peak to peak. So it has 8 volt peak to peak. Let's move now to step number 2. So this is step number 2. What I will try to do right now, I will disconnect the function generator from the oscilloscope, and I will try to connect this coil here with the function generator. So this coil right here will be considered as primary coil. It has 339 turns here. So that's great. So this coil right here is considered as primary coil. Now I will choose one of these and I will order them like 100 turns, 200 turns, and 661 turns. I will start with the 100 turns. Connect it to the oscilloscope, as you can see right here. Okay. So this is the secondary coil, and this is the primary coil. And you can see here that we don't have any signal, so that's clear. Maybe I can adjust the oscilloscope a little bit. So you can see that we don't have any signal here. What I will do right now, I will try to have this coil, which has magnetic field right now because there is a current flowing in this coil. So I will have it now to be entangled with the secondary coil. So what you can see here now, guys, we have a signal. So that's great. So let's remove this primary coil. There is no signal. I will have the primary coil again. So there is a signal. That's great. Let's now try to read this signal. Like how many voltages, how many volts do we have here? So what I will do right now, I will zoom in the oscilloscope monitor so you can read the output signal. Okay, so this is the output signal from the secondary coil, and as I mentioned that the secondary coil has 100 turns. I will try to adjust it, as you can see. So you can see here that we have like around 500 millivolt. So it is like very, very small signal. We got a very, very small signal. So the voltage peak to peak is 500 millivolt. So write that down. So you will need this. So 500 millivolt with secondary coil that has 100 turns. So now what I will do, I will move to the next coil. Okay, so I will remove the primary coil. So this is the secondary coil. So we are done with this one. I will remove it and put it here, and now use the 200 turns and see what do we have. So what I will do right now, I will try to have this primary coil, as you can see right here. So we can see that the secondary coil here has 200 turns and the primary coil has 339 turns. So that's great. So you can see now, even with this coil right here with the 200 turns, we can see that the magnetic field can create current. So there is no current flowing right now in this coil, but when we have this coil that has magnetic field, and this magnetic field was produced because the current moving in this coil, this primary coil. And here we have the function generator connected to the primary coil. So now let's have it again, as you can see right here. So you can see this signal. So that's interesting. And this is exactly the idea that people use to make transformers. So the transformers can be step-up transformer, so it can increase the output voltage, and it can be step-down transformer. So this step-down transformer can reduce the output voltage. Okay, so what I will do right now, I will read this output voltage. So let's do that together. And what I will do, I will zoom in the oscilloscope monitor. So let's do that together. Okay, so this is the output signal when we used coil with 200 turns as a secondary coil. So let's see what do we have. So we have 1 square 2, 3, 4, 5 times 500 millisecond. 1, 2, 3, 4, 5 squares times 500 millisecond. So this is the output voltage from this simple transformer. So you know that the primary coil has 339 turns, but the secondary coil has 200 turns. I used those two coils, the 100, the coil that has 100 turns, and the other one with the 200 turns, just to show you that you can get a signal. You can get a signal by having simple coil that can be made at lab. So those secondary coils, the 100 turns coil and the 200 turns coil, were made in the lab. So you can see that we have signal here. Yeah. 1, 2, 3, 4, 5 times 500 millisecond. Okay. Let's now move to the next secondary coil. Okay, so now we are done with this coil right here. The thing that I would like you to see is this phenomenon right here. So when we remove this primary coil out, there is no signal. When we return it back, you can see the signal. So this is the idea that people use to build transformers. Now what I will do, I will use this coil right here as a secondary coil, and we will see what will happen if we use this. So this one has like around 661 turns. Okay, and those blue ones, I just used them to show you to show you how the transformer work. Now let's see this one. So what I will do right now, I will connect the oscilloscope right here across this coil, this one. And what I will do right now, I will have, and you can see now, so that's interesting. Maybe I will move the camera right here so you can see what will happen to the signal here. Look at it. So when I keep this closer and closer, so you can see that the signal will start to build up. Yeah, you can see that the magnetic field from here induced current and make this current flow in this secondary coil. Now I will have the primary coil to be right here, and you can see like the huge output that we got. So I will reduce that down. Yeah, so you can see the output. So the input here is 10 volt, but the output here is 1 square 2, 3, 4, and I believe we have 4.4. So, 4.6. So you have 4 squares, 0.6 times 10 volt. Wow, so 4.6. So that's yeah, so that's 46 volt. That's great. And we got that from this secondary coil. I will remove the primary coil, so you can see what do we have. Nothing. I will return back the primary coil and put it here inside the secondary coil, and you can see the signal here. And also what I will do right now, I will zoom in the oscilloscope screen so you can count those squares with me, the divisions, the volt divisions. Okay, so let's do that. Okay, so let's count these squares for the last secondary coil that we will use for today's experiment. So 1, 2, 3, 4.4 squares. So we have 4.4 squares times 10. 4.4 squares times, sorry, so 4.6, yeah. So 1 square, 2, 3, 4.6 squares times 10, so that will give you 46 volt. The input signal has 10 volt. The output signal now has 46 volt. So you can see that here we have step up transformer, so we could manage to increase the output voltage just by increasing the number of turns for the secondary coil. So that's great. And also you'll learn that having magnetic field flowing in a coil, that can induce current. And that current, again, I will show you this figure. And that current, I will show you this figure again. Yeah, let's do that. Yeah, so you can see that this primary coil can produce magnetic field, and the magnetic field that can be produced from this primary coil can go through this coil right here and induce current or create current. And the number of the turns can dictate the output voltage, as I showed you. Okay, this is the end of lab number 6, and hopefully it is clear. I will include more explanation about the transformers when I post session number 1 for week number 6. Okay, so thank you.